You know, let's kick off this explainer with a thought that is probably going to completely upend how you're using AI coding assistants right now. You're not supposed to prompt Claude. You're supposed to build a system that prompts itself. Seriously, if you're sitting there manually typing out every single command for your AI, you're doing it the hard way. Today, we're talking about building systems that prompt themselves. This is a massive paradigm shift. We have got to stop treating AI like a passive chatbot that just sits there waiting for instructions and start treating it as an active, system-integrated agent. It's all about building a proactive workflow that works right alongside you. Look, the manual approach we've all been relying on, it's kind of failing us, and the data is pretty shocking. By relying on manual chatting, users are leaving a staggering 90% of the model's capability completely on the table. We're seeing 14% of efficiency lost right out of the gate simply because of missing context files like Claude.md. And honestly, it gets worse. 95% of users are completely ignoring the plugin infrastructure that makes these agents truly powerful. Basically, we're driving a sports car, but we're stuck in first gear. So here's how we're going to break this systems engineering challenge down today. First, the AI prompting problem. Then the context supply chain, the developer tooling gap, red squigglies for agents, and finally, the proactive agentic workflow. All right, part one, the AI prompting problem, and exactly why manual chatting fails. Okay, so no matter how ridiculously smart your baseline model is, it fundamentally lacks your team's unique context. I mean, its training data cutoff was months ago. It doesn't know your specific codebase conventions, like the fact that your team agreed to use bun instead of NPM. It definitely doesn't have your institutional memory. It has no idea that you already tried a certain architectural pattern back in Q3 and it failed miserably. And it certainly doesn't know about the internal APIs you just deployed last week. If you don't build a system to actively provide this context, your AI is literally flying blind. And that brings us to part two, the context supply chain, or how we actually go about feeding the AI. We really need to nail down the difference between two critical concepts here. On one side, you've got the model weights. These are frozen, they're read-only, and they represent the massive internet-scale pre-training. You can't easily change this. But on the other side, you have the context window. This is live, it's dynamic, and it's updated every single turn of the conversation. Customizing an agent isn't about altering its brain, it's about altering exactly what you're putting on its desk. Now this is where it gets really cool. The context window isn't just some static text box. It acts like a live automated conveyor belt of information. Customizing your AI is literally engineering the supply chain of that context window. You need to automatically pipe in the right files, the active conversation, and the tool outputs directly onto that belt so the AI has it exactly when it needs it. And the best part? You do this without ever having to manually type a single thing out. To feed that supply chain effectively, we have to talk about part three, the developer tooling gap, the terminal versus the IDE. Just think about it for a second. We build massive, highly reactive integrated development environments for human engineers, right? We get syntax highlighting, real-time error checking, autocomplete, the whole shebang. But today's default agent editor, it's basically equivalent to an isolated, primitive 1970s command line. Bridging the gap between that sort of primitive terminal and a rich, modern IDE is exactly where the massive opportunity for agentic workflows lives. But wait, the gap isn't just happening inside the code editor. Real engineering, as you know, lives everywhere else too. It happens in your team chat on Slack or Teams when you're furiously triaging bugs. It happens in CI/CD pipelines when builds suddenly fail. It happens in dashboards tracking error rates. Every single time you, as a human, have to leave your IDE to reach for another tool to get context, that is information the AI is entirely missing. If you leave the IDE, the agent's feedback loop is totally broken. It simply can't help you with what it can't see. So, how on earth do we fix this broken loop without typing prompts all day? Well, that brings us to part four, red squigglies for agents. I absolutely love this concept. We're co-opting a familiar developer tool, those red squiggly lines you get under a typo in a Word document or a syntax error in your IDE. But instead of doing it for humans, we're building infrastructure to provide these immediate automated syntax and logic corrections directly to the AI. We're catching mistakes the absolute moment they happen, which completely bypasses the need for a human code review. So how do you actually build this? Well, instead of waiting for a human reviewer to catch that the AI deviated from a code-based convention, you use post-tool use scripts. These are basically hooks that automatically trigger the split second the agent writes code. They lint the code diff, and if there's a warning, like say editing a generated file directly instead of running the generator, that warning is fed directly back into the context window as a corrective prompt. It all comes together in this really elegant 4-step process. Step 1, the agent generates the code. Step 2, your automated hook intercepts it and immediately runs your project linter. Step 3, the error feedback is piped directly back into the agent's context window. And step 4, the agent instantly self-corrects and refactors the code based on that error. What we're really creating here is an autonomous micro-iteration loop. This tight, incredibly fast cycle intercepts mistakes instantly. It turns errors into automatic corrective prompts that fix the issue before it ever reaches a human pull request review. You are completely removing the human bottleneck from error correction. You aren't prompting anymore, the system is prompting itself, and it's doing it using tools you probably already have lying around. Let's pull all these threads together for our final section, Part 5, the proactive agentic workflow. To build a truly proactive agentic workflow, it really comes down to a simple formula combining 3 pillars. First, access, routing your external telemetry, CI/CD logs, and chat directly into the terminal environment. Second, knowledge, actively bridging the gap between that internet-scale training data and your team's highly specific code-based conventions. And third, tooling, building scalable infrastructure and hooks for the agent, not just for the human. You do have to be pretty careful about how you're building these tools, though. Your tooling philosophy matters. You want to make sure you're building tools that actually scale with model intelligence. If you build rigid templates and super strict guardrails telling the AI, don't let it touch X, your system is going to degrade and become less useful as baseline models inevitably get smarter. Instead, focus your engineering on providing broader access infrastructure and faster automated feedback loops. Those are the tools that actually accelerate and become more powerful as the models improve. We started this explainer by pointing out a hard truth. Manually chatting means you're leaving 90% of your AI's capabilities on the table. The absolute fastest way to make your AI better at your code base isn't just sitting around waiting for a smarter model to be released, it's building a tighter feedback loop today. So what part of your manual workflow are you going to automate into a self-prompting system first? Thanks so much for joining me on this explainer, and I'll catch you in the next one.